Hello everybody, this is Ray Savage with Cambium Networks. Thanks for joining us today on the webinar. Today we'll be discussing the PMP 450 and quality of service configuration, and our special guest speaker is Justin Robinson, who is the channel manager in North America. The presentation is being recorded and it will be posted to the community later on today, and you'll be able to post your questions and discuss any topics there. Well, without any further ado, I'd like to introduce Justin.
Thank you, Ray. So thanks again, Justin Robinson, Channel Manager West North America. And today we're going to discuss a topic that has been intriguing as long as Canopy has been out. It's been how to configure the burst bucket, what it all means, and what settings are good for our network. So today we are going to briefly look at the burst bucket and some different examples with screenshots so that you can actually employ this on your own network. So with some of the objectives, the first thing that we'll look at is actually the Canopy frame structure itself. It's very important that we have this basic concept down, as it does dictate, depending on the application, how much bandwidth is going either on the uplink or downlink. And also these changes will have a dramatic effect on the total throughput for the sector in aggregate fashion. Secondly, we'll look at the Canopy token bucket concept and what it means and how it works. And thirdly, we'll give some real-world examples on service plans that can be offered and what some examples look like in the QoS tab of the SM subscriber module. And some target market examples will include our WISP deployments, municipalities or utility deployments, what kind of service packages they look at, and then one of our hot topics are video surveillance deployments. And again, these are just a few examples of the provisioning in the SM, as we won't touch on anything with VLANs or network address translations or radius. So this is just a pretty brief overview on just the MIR and the burst bucket for Canopy. So with that, we will look into the structure of the frame for Canopy. So the basic air interface structure of Canopy is comprised of originally 2.5 milliseconds or 5 milliseconds now with our latest releases. So with the setup for the frame, the AP communicates with the SM and the PMP protocol. So as you can see, basic frame size in one direction is 2.5 milliseconds or now 5 milliseconds, depending on the firmware that you are running. So by default, the downlink percentage is set to 75%. Most WISP operators will operate this in a 70 to 75% for the downlink. And again, that's because most operators like an asymmetrical package deal for their customers. So as you can see, we have in the uplink and downlink, so you can see in the uplink and downlink with the setup. All right, you can see the packets are with the data packets are skewed in with the framing. So when you look at the airframe in general, you'll see that On the downlink side, which is the transmit side from the AP, on the first stage is the beacon. So this will consist of the color code and the max distance. After that, you'll have the scheduling for the uplink on the next packet. Then you'll have acknowledgments, and then we'll actually have the individual data stream itself, followed by the guard band or guard time, and then on the other end of the frame we'll have the AP uplink receive, which consists of the acknowledgments, data, and control slots. So the big thing is with anything that's TDD, we have the guard band or the guard time so that the AP actually stops transmitting so that it can listen on the same channel. So again, like previously mentioned, in the first parts of the frame are the beacon and the uplink and the acknowledgments. And again, acknowledgments, they're variable, so they can be based on activity and demand. So data slots are fragmented in 64 bytes. This has long been a benefit of using Canopy. So if you're ever in near a non-line of sight condition and part of the fragment of the packet does not get through, it won't retransmit the entire packet, just the byte, the 64 byte fragment that was not received. And then on the uplink, we have the control slots, which are set in the AP, and we actually have a reference to how many control slots or contention slots you will need per SMs on your sector for that. So in this last example for the airframe, the big thing here is how it's flexible, so we can change the percentages. So again, by default, it comes as 75% downlink. So what that means is that 75% of your frame is actually consisting of the data packets. And again, the SM will adjust this based on the AP's information that it sends out in the scheduler. So now that we've talked about the frame, let's look at the burst bucket. So this is the most infamous picture with Canopy, our burst bucket. So what does it mean? How is it used? This is probably one of the biggest questions that is brought up in dealings with people with Canopy is how does it work? So this is a good illustration that kind of talks about the water flowing into the bucket, which is our maximum information rate. And then we have our burst size, which is burst size or allocation, which is literally how much is in the bucket. So you can either think of it as liquid or tokens. And then we have this overflow where when the bucket gets too full, that the radio has to release some of that excess bandwidth. The bucket size, and then we have how much we get let out, which is less than the maximum burst rate. So this is the formula that we have used for years, where it's the MIR times the burst duration plus the burst size equals the maximum burst rate times the burst duration, whereas the burst duration is equal to the burst size divided by the maximum burst rate minus the maximum information rate. So sometimes, especially for me, this was not the easiest thing to look at and compute. So we're going to work on trying to give you a real-world example and get it a little easier. All right, so looking at this example here, taken from our MIR settings on our SM, the first two columns at the top, the sustained uplink and sustained downlink. The uplink is set for 5 megs, and the downlink is set for 15 megs. So those are our sustained rates. Our uplink burst allocation, as you can see, is set to 170 megabits, and our downlink burst allocation is set to 200. Now, the biggest thing to remember is with the allocation, this is not a rate, it's a quantity. So this is actually the amount that's filling the bucket. So remember, it's not a rate, it is a quantity. So it's how much is filling. And then we have our max burst uplink and max burst downlink data rate. set to 7 megs and then 20 megs respectively in the uplink and downlink. So based on these settings, the first thing that we need to calculate is actually the true burst rate. So the way that we figure that out is we take a look at the maximum burst rate in the downlink, which is set to 20 megs, minus the sustained data rate, which is 15 megs, which actually gives us 5 megs for bursting. So you have to remember that we already have provision in the pipe 15 megs for sustained rate, and we're saying for the bursting that we're going to make that pipe up to 20. So the difference is going to be 5 megs. So with the available resources on the networks and with the right RF settings and conditions, your SM will burst 5 megs over your sustained rate. But the million-dollar question is normally, for how long will this last? WISPs like to know, any kind of operators like to know exactly how long it'll last so that they can make sure that they scale the customer down to what they're paying for. So the way that we figure that out is we'll actually take the downlink burst allocation, again, how big the bucket is, 200 megs, and we'll divide that by the burst difference, which is 5 megs. So 200 divided by 5 gives us 40. So that burst duration is going to last 40 seconds, where the customer will get 20 megs before sustaining at 15 megs. So this 40 number is very important because not only is that the time it takes for the bucket to extinguish, but also that's the amount of time that it takes for the bucket to replenish as well. Because again, it's not a rate, it's a quantity in the burst allocation. So knowing that, we'll look at a couple of examples of different service plans that we've seen in some deployments. So in a typical WISP deployment with bursts, the first setting you'll see in the upper right hand is actually in the access point. So this is where we consider the frame. So earlier when we saw the picture of the actual frame, this is the settings that we would use to manipulate the data slots. So we have the max range and then the downlink data. By default it's set to 75, so here we set it to 70. So with that, in the subscriber module of the MIR, we have a downlink sustain of 5 megs and an uplink sustain of 3 megs with bursts of 15 megs down and 13 megs up. So remembering the math that we did before of taking the downlink burst allocation of 150 megs, dividing that by our difference between our burst and our sustain of 10 megs, we'll see that we have a burst duration of 10 seconds. So in another example of a WISP deployment, we see the exact same settings in the access point, but as you can see on the MIR settings in the SM, the big difference is we have 0 for the uplink and downlink burst allocation. So by default, the max burst uplink and downlink, when you get a subscriber module, is set to 0, which means that it's uncapped, which means that it will burst. So what we do is we pretty much empty the bucket completely so there's nothing to spill out or to use. So that's where we use in the uplink burst allocation and downlink burst allocation of 0. That way there's nothing in the bucket that we can use for an overage. So with no tokens in the bucket, burst is negated and your customer just has a sustained rate of what is set in the uplink and downlink. So in this example, 5 megs and 3 megs. So in an enterprise setup, this could be TDM replacements or business-to-business customers or municipalities or anybody where they want a more symmetrical service. This is an example of a setup. So in the access point, for the uplink and downlink, we set 50% for the data. So again, this is an aggregate figure. So let's say that the conditions, you had 100 meg AP, 50 megs would be allocated for going down, 50 megs for coming back up. So in the SM, we have a sustained downlink and uplink of 10 megs with no bursts. So again, we see this typically if you have lease line replacements or providing smaller bandwidth circuits to business customers or campus environments for remote buildings where they don't want any bursts, they just want a constant sustained rate. So this is an example of that provision. So video surveillance. So one of Cambium's hotbeds, especially with the release of our new 450i product, we're seeing a lot of need for uplink or upstream transportation. So with that, as you can see in the AP, we've actually changed the downlink percentage only to 30. That way we can have 70% of that bandwidth actually heading up to the access point, which is what you need with video surveillance. You need all your bandwidth going up except for, say, PTZ control, or if you are running any kind of I/O gear off the camera. That's when you need that small allocated amount going downstream. So we have it set for 30% down, 70% up. In this example, we have a 20 meg sustained uplink with a 2 meg sustained down. So one of the big things is depending on what cameras you guys are using in the settings, you can set it to where if the camera has a little bit of a spike increase due to the cut filter, or depending on the type of codec that you're running, you can set that a little bit of a buffer in the uplink data rate or the downlink data rate. And again, the flexible frame and the MRS settings are ideal for video transport in the 450 and newly released 450i. So the last caveat I will say for this, which I brought up earlier, is these are all aggregate figures. So remember, depending on how you have the downlink data slot set for the access point is going to impact how much bandwidth you have going one direction or the other. So be diligent, and we do have a capacity planner tool that is available online at cambiumnetworks.com under support for the 450 that will actually help you in planning out your network. WISP operators will have a different oversubscription need than, say, video surveillance deployment or business-to-business customers. So as long as everything is planned out properly using Link Planner and or the capacity planner, we feel that these settings will help you make sure that your guys' network is not being overutilized and is making sure that your customers have a great experience on Canopy. So with that, thank you for your time today, and if there are any questions, you can post them in the forum, and I can make sure that I answer them. Thank you.
Thanks very much, Justin. Thank you, everybody.